Limit the exam. Where is the exam? At what time? Over. Somebody thinking from that side. They want to think this all. If this exam over, time is it? Because exam. Yes, sir. Class take book. Mark problems. 54, I may not be able to teach everything. I'll teach how many I can. You also want that. Why to waste time? Page 58, problem 46, 48, 51, and 54, 60, 68, or something we have all know. Like, and only, and I don't know, like, 73, 74, these are the number of points we have faced. 70, we enter 74. You try, these are all good problems. You can try, you should. No, this is x square. Normally I have drawn x square minus x minus 6. The roots are, it is 3 right? The maximum value, the minimum value we get at 1 by 2. So something like this I have drawn. When we want to put modulus inside g of mod x, I remove this portion and then draw it slightly it should fall. Draw it and then again immediately once you draw that, then again outside modulus, whatever you have the below, flip everything up. This you have a W you look like that. So you will get and then one will kind of thing. And then again graphical transformation. Somebody asked me. What do you need? I think most of the mistake is the hiding composition is both are non-uniform. Except on draw the graph. Which one we are keeping inside and draw the graph of f. You know the graph of f. We will say like normally x by sin x by x is there. That one will approach one when we are approaching 0. Like one inequality is there. Sin x will be always x. So if you divide the x on sin x by x will approach 1, but technically it will be always less than 1 in the neighborhood. If you put greatest indicer of something less than 1, you will get 0. So same concept we are using. When x approaching unit of x approaching 0, right? Sin of f of x by f of x will approach 1. But like technically it will be slightly smaller than 1. It's slightly smaller than 1. If you put greatest indicer, the inequality was less than tan x. For tan it will be slightly greater than 1. That's why you get inverse trigonometric also we have some yes, please. Why discontinuous? Remember continuity differential how much? Right hand limit is how much and f of 0. Right? And the third one, f1 also. This is the actual procedure. Can you see any breaks in the graph? Anywhere it is jumping up and down, then it is continuous. So then we'll continue solving problems. Yes, very simple. Can we start? Please stay quiet. 46 we are doing. 46 problem we are doing. Can you hear me, online students? Thank you for responding. Thank you, thank you. 46, please read once. This is another type. Instead of giving two different functions, what they have given? Max of only one function, that is sine function, sine t, such that 0 less than or equals t less than or equals x. What is the interval for x? 0 less than or equals x less than or equals 5 we have. Correct? Right? So now in this, please settle down and don't make any noise. Sine graph only. I'll teach. Ah, straight line, perfect. Then you can solve by yourself. So like here, given function is f of x is equals to max of, that means maximum of sine t, such that 0 less than or equals t less than or equals x, where 0 less than or equals x less than or equals, we have 2 plus cos x. This one when x is greater than y. So graph is required for this one alone. Let me draw the graph of sin x in the interval 0 to pi. This part says I will consider the maximum value of sin t when t is varying in the interval 0 to x, where x is there in between 0 to pi. If you notice, till pi by 2, it is increasing, 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 right? You take some values t1 and t2, right? I can say for t1 less than t2, sin t1 will be less than sin t2. You increase the value of x, sin x will be increasing and going. At pi by 2, it reaches maximum, from there it is decreasing. Right? What happens to this function is, if it is reaching maximum, it will take the function. Once it reaches the maximum, it stays there. It won't come back. So like I can say here, it will be f of x is equals to sin x when 0 less than or equals x less than pi by 2, equality you can put here, and it will be 1 when pi by 2 is less than x less than or equals to pi. See, like this is for maximum case. Once we reach maximum, it will stays there only. It won't come back. It won't come down. Clear? If they are talking about minimum, listen carefully. If they are talking about minimum at zero only, it has minimum. It will be staying at zero till pi. Do you understand my point? Any doubt in this? Since it is increasing, it took sin x. From there, it started decreasing, so it will stay there only. Clear? Minimum, if they talk, at zero itself, it is minimum. You move up, you are having maximum only, not minimum. Till pi, it will be same. Maybe if you have below pi, in that case, sin x, till 3 pi by 2. Clear? Understood this one? Any doubt? Now, after this, they have given us 2 plus cos x. This 2 plus cos x when x is greater than pi. See, like few students are still having some doubts. How sir is telling about continuity and differentiability at this. First of all, after seeing this, sine is a continuous function in the interval 0 to pi by 2. Doubt is at pi by 2. Clear? Again, one is constant function, continuous pi by 2 and pi. Doubt is pi by 2 and pi only. Clear? Same thing for 2 cos x. At pi only, I need to check. So, first of all, for continuity, right? So, 3 points are there, starting with pi by 2. What we are doing, we are checking at x is equals to pi by 2. So, can you tell me how much is left hand limit at pi by 2? Sin pi by 2, that is 1. Right hand limit at pi by 2, function value at pi by 2, that is also 1. Therefore, continuous. Am I clear? Now at x is equals to pi, not continuous pakkava. Let us see how much is left hand limit at pi. Left hand limit is 1. Right hand limit 2 in plus cos pi. Cos pi is minus 1. So 2 minus 1 is 1. F of pi will be equals to 1 again. Continuous, right? Correct? So now uh, continuous, I can say. Now what about differentiability? Now differentiability we can say here, maybe writing here. In case of differentiability, first differentiate the function. F dash of x is equals sin x. If I differentiate, I'll get cos x. Please remove the equalities. 0 when pi by 2 is less than x less than pi. Minus sin x when x greater than pi. Doesn't matter, every inequality I removed. Clear? So now check. At pi by 2, how much is left hand derivative? 0, right? So at x is equals to pi by 2, LHD is equals to cos pi by 2, 0. RHD is still 0. If you notice here, like if I draw the graph this side of the function f of x, you might think like there is a corner set. At pi by 2, something like this, it will, from here, it will go. Students thinks this is corner at pi by 2. Corner or smooth turn or like sharp turn depends upon the derivative only. By seeing, sometimes we might misjudge like this. Clear? So next, what is the another point? Pi I need to check. At x is equals to pi, how much is left hand derivative? 0. Right hand derivative is also 0. Now what I can say? Function is continuous everywhere, differentiable everywhere. Now which option I need to pick in this? Understood this one? Any doubts in this? Anybody? Last bench, Tarun, Chris. This side, any doubts from girls? No doubts. Copy this. Online, any doubts?
Sir,
Yes, please.
so why did you take sin x for maximum value?
If the function is increasing, maximum value will be function itself. If the function is not increasing, in that case, where it is starting or where it is reaching the maximum, that will be the function. Like I think this one you should understand with some examples only. Maybe I'll put more problems in next class, then maybe you'll understand. Depending upon increasing and decreasing nature only, we'll write this. Then what else? Problems we'll solve again. Let us continue with concepts. Anybody writing this slide? Any doubts in this slide? What about this slide? Shaktivela, what is your name? Any doubts? Understood, right? Any doubts? Anybody writing this slide? No, right? Then let us continue with the concepts. There is something called continuity of a derivative. Function f is there, no? We check continuity. What about f dash x? That is continuity of a derivative. Put one small subheading. Please conclude these things. Why it is, which option we are picking there. Continuity of a derivative, or we are checking whether f dash is continuous or not. At one point, we are talking. The derivative of the function f is said to be continuous at x equals to a. That means we are talking about continuity of f dash of a. First thing, f is differentiable at x equals to a. Second thing, f dash of a minus is equals f dash of a plus is equals f dash of a. Clear? If you take in this way, g of x is equals to f dash of x. We are saying here the function g is continuous if left hand limit at a is equals right hand limit at a is equals function value at a. That's what continuity of a derivative means. Clear? So like we can take, there are some examples which are continuous, there are some examples which are not continuous. Clear? So maybe I can say page number 59, problem 62 is good example, where they have given one oscillating function and quadratic equation x square. Page 59, problem 52. If you read that one, what they have asking in options is like f is continuous but not differentiable. F and f dash both are continuous. F dash is continuous but not differentiable. F is continuous but f dash is not continuous. So we need to check which of the following options is true here. Clear? Do you understand the continuity of a derivative? Can I scroll up? Can I scroll up? Any doubt in this? So function f of x is equals to x square into sine 1 by x. When x is not equals to 0, it will be 0 when x is equals to 0. What do you think this function is continuous at 0? See, this function does not have two limits at 0 because like x square and sine 1 by x. There is no mod, there is no greatest integer. So like only one limit is there. I can say limit x is approaching 0, f of x will be equals to limit x is approaching 0, x square into sine 1 by x. I can say here this is 0 into some finite value we have in between -1 and +1. If it is 0 into some finite value, we get 0. This is limit, and then function value is also equal. Therefore, I can say f is continuous at x is equals to 0. Any doubt in this one about continuity of f at 0? No doubt, right? Understood this one, right? Now let us find what is f dash of 0. To find f dash of 0, I am not using the differentiation directly. As I said, there is one more method, first derivative method. I can say f dash of 0 will be equals to limit h is approaching 0, f of 0 plus h minus f of 0 divided by h again. Clear? So only one side now we'll consider right hand derivative by default. So like now this will be limit h is approaching 0. We have h square into sine 1 by h minus 0 divided by h. One h in numerator and denominator will get cancelled. Limit h is approaching 0. H into sine 1 by h we have, right? Now if you notice, you have 0 into some finite value. 0 into some finite value will be equals to 0. F dash of 0 is also equals to 0, that is finite. F is differentiable at x equals 0. One. My dear students, that is only if h is approaching infinity. See, like sine of f of x divided by f of x will approach to 1 when f of x is approaching 0. So what is 1 by h approaching here? In that case, it is not true. Clear? Clear? See, like again, as x approaching a, f of x approaching 0, then limit x approaches a, sine f of x divided by f of x will be 1. Here h is 0, but 1 by h is not 0. That is infinite. It is not 1. Any other doubts? So like now what I can say, I can say f dash of x will be equals to. At non-zero, I'll differentiate this function to get f dash of x. At 0, I already found derivative, that is 0. So if I differentiate x square into sine 1 by x, I'll get 2x into sine 1 by x minus cos 1 by x. I hope this is clear. I have applied u into v rule. X square 1 by x derivative is, so x square there and x square here will get cancelled, right? Anything else? Right. So now I can say here. Yes, please. Sin 1 by x will be some finite value in between -1 to +1. Maybe if you need some argument, I can say for any input, sin will be in between -1 to +1. You can multiply with h on both sides. Minus h less than or equals h into sin 1 by h less than or equals to h. The moment if I take limit h is approaching 0, I'll get minus h less than or equals limit h is approaching 0, h into sin 1 by h is less than or equals limit h is approaching 0, h is. So we have 0 less than or equals limit h approaching 0, h into sin 1 by h is less than or equals to 0. From sandwich theorem, it must be 0. No, minus only no. X square sin 1 by x derivative is cos 1 by x. Derivative of 1 by x is minus 1 by x square. X square in numerator and denominator gone. Now, so like what is first option saying? At x equals 0 only they are talking. First option says, please stay quiet. F is continuous but not differentiable. F is differentiable as well, discard it. Second option, F and F dash are continuous. F and F dash are continuous, they are saying. So need to be checked for F dash. F is continuous. F dash is continuous but not differentiable. F is continuous but F dash is not continuous. So four options are there. Now I need to check about continuity of F dash. Right? F dash of 0 is 0. What is limit? H is approaching 0. Sorry, x is approaching 0, f dash of x value. How much I get? Please listen carefully. Some 0 into finite value, I'll get 0. But this one is oscillating in between -1 and +1. So I can say this one does not exist. Do you understand why this one does not exist? Right? Oscillating in between -1 to +1. If this one does not exist, I can say f dash of x is discontinuous at x equals 0. Do you understand this argument? Right, please. Now our proper option is fourth option. F is continuous but f dash is not continuous. Any doubt in this? Anybody? No. Then copy this. This is about continuity of a derivative. Some doubt? Roll. Okay. Don't sleep when I'm teaching calculus. Maybe you guys are having like how to tackle maximum only one function is given, minimum only one function is given. Let us find one problem on that to get clarity over that problem. Uh, can you go page number 72, problem number 8? It is about like how to tackle this minimum only one function is given, maximum only one function is given, that kind of problem. Page number 72, problem number 8, I am talking here. I think some online student asked some doubt about how to tackle maximum and minimum. Please pay attention in this problem. We'll try to explain how we are tackling again. Please read that problem once, go through it, and then try to figure out a what you say map or blueprint kind of thing. How are we going to tackle that one? Sujit, are we done in this? So Vishnuvardhan, please listen again. Here also I'll use graphical transformations. Page 72, problem number 8. If you notice that there is like a big problem where modulus is involved, maximum and minimum is given, f of x is equals to x square minus 2 into modulus of x. Now, g of x is defined based upon maximum and minimum. They have said minimum of function f minus 2 less than or equals p less than or equals x, and then minus one moment 2 less than or equals x less than or equals 0. Maximum of f of t such that 0 less than or equals t less than or equals x. So 0 less than or equals x less than or equals 3. I am drawing this graph. First of all, x square minus 2x graph, if we draw, it has two roots passing through origin. One root is x is equals to 0. Another root is x is equals to 2. This is the graph of x square minus 2x. When I am keeping mod x in place of x, I need to identify the portion which lies left side. When x less than 0 portion, you need to remove it and then take image of x greater than 0 portion. Now we will be having, so this is when I hope this much is clear to everybody. X square minus 2x. This side you have x square minus 2 into modulus of x. Notice that they are talking about minus 2 to 3 interval, right? So this is minus 2 comma 0, 0 comma 0 over here, 2 comma 0. So our parameter t is starting from minus 2 and it is varying with x. Clear? So till 0 we should consider maximum. Listen to me carefully. Till this point over here, function is decreasing. Function is varying with x here. Decrease, decrease, decrease. Once it reaches minimum, it stays there and then till where? Till 0. So now if I see with red color I am trying to draw here, starting minus 2 and then till this point. This point if you want, that is vertex of the parabola. That vertex is minus 1. X is equals to minus 1. Y value you can get by substituting x minus 1. Do you understand this? From here, it stays minimum. I need minimum only. If I'm moving up, it is not minimum. I'm moving increasing the value. I don't want that. Once I reach minimum, I should stay at that point till 0. Right. So this is what I'll be having. Any doubt in this? Till 0, this is what I do. Understood this one? Any doubt in this one? Now again, what we are doing next? We are doing next in between 0 to 3. Something we are doing there, what is happening here. 0 is there in both the cases, huh? 0 should not be there in both the cases. Okay, leave no worries. We'll tackle that one. Now maximum I need in the interval 0 to 3. So like listen, if you start from 0 till no, like listen, till here it is decreasing, from there it is increasing. Even though it is decreasing, increasing, its maximum value is at 0 only. Clear? So it stays there only till what? Till 2, right? So from 2 onwards it will increase. Like this will be a straight line like this. From 2 it is increasing with this graph till what? Till x is equals to 3 line. Understood this? Any doubt in this? Anybody? I think 0 should not be there in both the cases. One case, sorry, that's what, any one case only. Some printing mistake. First option, then it is true. Do you understand now? Using graph, I'm telling, please listen. Right? Now, at 0, if you notice, I am removing 0 from this. I am including 0 below 1. Clear? Both are 0, na? Function is different, not different. So, at 0, there is clearly a jump. Correct? Discontinuous at 0. Do you understand this? Everybody understood, right? So now what about remaining? Like maybe for remaining, I should know about when x is -1, how much is this function? Can you calculate? When x is -1, how much is x square minus 2 into modulus of x? -1. So this is -1 here. So like now, what we need to find in second option, g dash of -1/2 and g dash of 1/2. How to tell about it? Now I can say function g is constant in the interval -1 to 0. Again, function g is constant. If I differentiate, how much I'll get? 0, right? Understood? Any doubt? So next, 4 times of g dash of -3/2. -3/2, na, this side I'll write and show. And then g dash of 3, na, that side I'll write and show. G is non-differentiable at 2. Maybe for that, I need to know about the definition of function in detail. So this is function g of x is equals to this is x square plus 2 into x when 0, oh sorry, -2 less than or equals x less than -1, and it will be equals to -1 when -1 less than or equals x less than 0. It will be 0 when 0 less than or equals x less than 2. Then from there it is changing x square minus 2x we will get. This is when x greater than or equals to 2. Maybe they stopped at 3. Clear? See, like how do I wrote actually this one? This graph is x square minus 2x. This graph is x square plus 2x. Mod x I have broken into two parts. Clear? So now you can see at, as I said, at 0 it is discontinuous. And then g dash of 1/2 and -1/2. So how much is g dash of 1/2? 1/2 is there. Listen, I am differentiating in this interval. 1/2 is there. Derivative, if I do, I'll get 0 only. Now g dash of -1/2, if I am doing in this interval, I am there. Constant derivative is 0. Clear? So this is second option. Third option is about g dash of -3/2 and g dash of 3 here. So for -3/2, let me do that. G dash of -3/2 will be equals to. So how much we'll get? This interval I should take 2x plus 2. X is -3/2, 2 times of -3/2 and plus 2. How much is this one? -1. So next we need to check for g dash of 3. So g dash of 3 now differentiate this. We have 2 into 3 minus 2, right? So this is 4. What do you think it is true there? Not true. Sign is changing, no? One is plus, another is minus. Now g of x is non-differentiable at 2. What do you say about this? Then it seems true only. G dash of 0 minus is 0. G dash of 0, oh sorry, not 0, 2. G dash of 2 minus is 0. G dash of 2 plus is 2 into 2 minus 2, which is not equal. So then can somebody check? We got correct answer, or we need to verify our calculations one more time? 1, 2 and 4 we got. Okay, then thank you. I hope this one removed all your doubts about how to take maximum and minimum when only one function is given. Understood? See, like, again, please pay attention. Do you understand about this? It is x square minus 2x. X square minus 2x. This is x square plus 2x. I have seen that red color mark is like from minus 2 to minus 1, it is the function itself f of x. That is x square plus 2x. From here to here, it reaches the minimum, no? It stays at the point minus 1, right? As we assume the 0, we are not considering, we will consider 0, right? From 0 to 2, it is y equals 0. From 2 to 3, it is again the, that's what I wrote here. You want, you check the continuity, and you want differentiability, you differentiate and check. Any doubts in this? Understood this one? If you are feeling sleepy, go watch the video. Understood this one? Any other doubts in this?
Sir, how did you find the minimum value as minus 1, comma 1?
Like that is vertex of the parabola, no dear. For the parabola, upward parabola, minimum occurs at the vertex. Vertex is minus b by 2a. That is x coordinate. Y coordinate is minus d by 4a. Or else substitute x equals minus 1 in that. Anything else? Understood this one? Any other doubts? Can I scroll up? You can write. See, like, just change that one. 0 alone, I removed from first case. Any doubt is there, please let me know so that I can help you. Ax square plus bx plus c is a parabola, can be upward or downward. The vertex of the parabola will be at minus b by 2a comma minus d by 4a. D stands for discriminant. Clear? It is symmetric about x is equals to minus b by 2a line. Mirror image this side and that side it works. So then more difficult sums if I teach you are also. Then solve some problems. Before I think you are not here, that time I marked some problems. Let me say those numbers again. 46 I only thought. 48 you mark. 51, did I said 51 earlier? 51 you mark. 54 you mark. 60, then 68 directly. In between I didn't said anything. 63 and oh, that already solved. 68, 70, 70 is there, I think. 73, 74. These are all good problems. Try once. Do you want me to discuss methods of differentiation, composite function, chain rule, implicit function? You want that? Okay, then I'll plan. I think 1 or 2 day I posted only for limits. In one more class I'll be done. I don't think anybody attended. No problem. I'll post the notes if you want. I didn't post it yet. No. That is this class. Till what I thought in last. Today also I'll post, but limits I'll post separately. What I thought in video. Anybody writing anything here? Do you understand these all things? Please say yes, no. Yes, right? Okay. Then we have methods of differentiation and mean value theorems. So you have some solid 30 minutes. I would expect you to do at least some 5 to 6 problems in this solid 30 minutes. What I have marked is those are all difficult problems, not so easy to tackle. Maybe if you want some basic problems, you can go to the in-book exercise or in-book examples you can solve. If you are confident enough in this continuity concept, you can solve step 2 PYQs. Clear? Like, don't waste time in discussing or having some chatting with your friends. Better learn something or solve something. If you have any doubts, you ask me, I'll teach here. So now, dear Vishwanath, you are saying something, some doubt is there. Clear. So if anybody solved any problem from continuity and differentiability, if you have some doubts, maybe you can ask me, I'll help you. F of x is equals 1 by, that is not defined when x is integer. Hmm. Then remaining case, no, not defined means function value does not exist. Definitely discontinuous, no need to think. Then what do you want to talk? Huh? Asymptotes you want to. I think I don't know how to draw that graph. That is trickier. Like in between 0 and 1, it is 1 by x. 1 and 2, it is 1 by x minus 1. 1 by x minus 2, and so on it will go. So, not sure how exactly they draw. Definitely not differentiable at any integer. Huh? I need to work on those graphs. Not sure. Anything else? Maybe this time I'll take to mark attendance. Anybody knows yesterday, those are last round concluded. Any of your friends, cousins, seniors got some good colleges, there is some good movement in that those side seems. Joint seat allotment, the one which is responsible to allot seat, IET and ME. No, don't know anybody. So he got what he got. Super. Which branch he got? Which branch he got? Oh, super. Then any other stories like this? That one you should take as inspiration and you should do well for your exam. I am not here, no. I was in Akash Salem. From there, one student got IIT Bhubaneswar CSC. Yesterday only he told, sir, I got IIT Bhubaneswar. But our branch, I don't. I am not here, no, last year. So no connection between your seniors and me. What halogen doing in maths class? Huh? In maths class only you should have some math terms. See, if you want to test me, bring some problems maybe from what book you are using, Arihant, some good examples, engage some good example. Or maybe if you have some Alan or some other modules, bring them. Maybe there I might get stuck. Huh? I didn't know. What really? Say loudly. But it's very clear. Yeah. It's like normally what are functions we cannot do like that. Don't draw the graph. Graph is needed for this. Identify the definition. Just identify the definition and write in this way. After writing in this way, differentiate, change the idea. This is tricky or found the limit values is always marginal. But if the countries in between, something is there. That's what. If it is approaching towards minus 2, if you are minus 2 from there, it will be calculate. Equal zero, I believe that is minus 1. Anyway, how much is 1 and x is 0? How much is that is point out. And then last case, that is this much only. Then it will be 1 and x is greater than or equal. Now you think. What do you think? Also, less than less than or equal. Starting what do you find x plus 1 and x plus 2 by x plus 2. What x will be always less than 1. This side anything 0 less than 1. What x less than 1. So what x is here? We have 0 less than 1. We need greatest integer of the for 0. Then you draw 2x and which one is lying above? One is not. Did you draw mod x? Did you draw 2 minus x square? Minimum you found out. Minimum only. Found out. So then this one you write as 2 less than mod x. In that case, greatest you are when mod x equals 3, greatest integer value is 3. Now please stay quiet. Don't sound like that. See, if you want me to draw, I'll draw. Uh, One moment. Right. So they need what minimum? Minimum means clear. So this crosses in between what and what? Clear? Sorry? Hmm? No, roots are plus minus root 2 only, no. Not minus 2 and plus 2. So this is what I'll get the graph. Now, in between 2 and 3, the graph is 2 I'll get y equals to 2. At 3 I'll go now tell me what you need. I think at minus 2 it is discontinuous. What is the interval they are talking about? Minus 3 to plus 3. Minus 2 it is discontinuous. 2 it is discontinuous. Open bracket they are talking. So 3 and minus 3 I am not checking. Right? So now differentiability what I can say. Non-differentiable at this some point we don't want maybe minus 1 or plus 1. Alpha minus alpha you can say two non-differentiable points. Then what else we have? Oh, 0 is also there. Yep, 0. How you know? Hmm. Then why you are getting 4? Why you didn't include? See, box will be this one. This is y is equals to 2 in between 2 and 3. Like 2 and 3 and minus 3 and minus 2 as well. At 3 and minus 3 it will be 3. Yes, please. Uh, oh, how you checked? Differentiation. Use first derivative principle. First derivative principle. This one. Limit h is approaching 0. F of at minus 2. Minus 2 plus h minus f of minus 2 divided by h. Did you use this one? Use this one. Sin x by x and all trickier one. Thirteenth. Page number? Huh? Oh, that one. What you did? Huh? No idea. We should have some idea, no? See, uh, greatest integer 4x. A range if I find for 4x. 4. Normally 4x range is 0 to 4. Range open only both sides, but 0 to 4. Integers are 1, 2 and 3. But 4x will be 1 at x equals 1 by 4. A 1 by 4 in multiplication, what you have? That is 0 only, no? X minus 1 by 4 whole square will be 0 at 1 by 4. That will neutralize the discontinuity. So then at x equals 1 by 2 again, greatest integer of 4x will be 2. 2 are like less than 2. Discontinuity point might be there. But x minus 1 by 2 presents, neutralize it. Then how much is remaining? X equals 3 by 4. One discontinuity point. Now break it. 0 to 1 by 4, 1 by 4 to 1 by 2, 1 by 2 to 3 by 4, 3 by 4 to 1. Differentiate and check. If you break in this way, before itself you would have got. Ah, that one won't work in all situations. See, like if I use the same method here, where we have studied about derivative of a continuity, where it is here. If you use directly f dash, you differentiate and put 0 here also, it won't work, no? We need to be careful in some situation. Clear? Here also, directly differentiate, put 0, it won't be satisfying. This is not actual function, it is redefined one. In that case also, at minus 2, not defined. Clear? Understood? Hmm. Uh, to my dear online and offline students, I would like to say thank you for attending this class. Hope you learned something new. We'll see again in next class. If any doubts is there, weekdays I'll be here only. Morning time you can come. Evening time I might be busier with evening classes. Thank you. That's it. You can go for break if you want. You can go for break.